Hey everybody, welcome to the Ignited Podcast, Striking Industrial Automation Conversations. We're your hosts. I'm Travis Cox.
And I'm Thomas Burke.
This episode is called Interoperable, the journey to open process automation with Don Bartusiak.
So today we are exploring Don's journey with OPA, Open Process Automation, how far he's come and we've come, the challenges that he sees still ahead, and the transformative possibilities that OPA promises for the next generation of industry. Don, thank you very much for coming to the show. Can you give us a brief introduction about yourself and your background?
So I'm a chemical engineer. I'll just comment on professionally. And I first started, my first job was as a process development engineer in environmental. I was an idealistic young man. I always liked the math and stuff, so then I went back to graduate school after working for a few years, and that's when I got into control. So I probably marked my start time in control back to about 1984. So, it was funny. I had worked for a big company, and I told myself I'd never work for a big company again when I went back to graduate school. But look where I ended up.
Yep.
But honestly, and I do want to actually tell this story, particularly maybe for the young engineers and people just starting out their careers. I really liked the way that ExxonMobil treated its staff as professionals, and it really literally changed my mind. And I never regretted hiring on with ExxonMobil. I started in late 1987. Anyway, so I joined ExxonMobil relatively late in life compared to where young people enter. So my career was somewhat atypical. I spent almost all of my time in the process control discipline, 33 years from start to finish, somewhat atypical for a company that likes to develop talent by moving them around and stuff like that. But I was turning down jobs. Anyway, I'm probably being too detailed. So I basically climbed the ladder, again, almost always in process control, but I went back and forth between, technical jobs, starting supervisory jobs, back into more senior technical roles, back into higher levels of management, back and forth across the so-called career ladder. And that was really, really important because you really see the breadth of issues that's required, to run a profitable business. So that's maybe a long run up, and I'll let you ask the next question, Tom or Travis, about maybe the OPA journey.
And I will, Don. I will.
So before we get into the OPA journey, right. we do this little segment at the beginning of the episode is, we're in an industry, Don, where there's lots of technical jargon and terms and acronyms and all sorts of crazy stuff out there, which we're going to be sharing quite a few here today, I'm sure. So we do this segment that is called Real or Fabricated, where we're going to give you, Don, four terms or acronyms, and you got to pick out the one that is fabricated, is the wrong one of the group.
Hat on. Okay.
All right, so the first one is OPAS. The second is IEC 61499. And the third one, Stiction. And the last one is TSEL, T-S-E-L.
I think they're all real.
Which one you think is the fabricated one?
The fabricated one?
Yeah, the one that's not real.
The one that's not real? TSEL. Well, Stiction is certainly used. Yeah, it's certainly a phrase that's used. I don't know if it's in the dictionary or not. I think engineers would know what Stiction is.
All right.
Lay people might not.
So which one do you think? Is it, you mentioned there, you said TSEL.
Well, TSEL isn't that something having to do with immunology and the things that are in your body to protect you?
Well, that would be if there was a C. It was TSEL, T-cell.
Oh, TSEL. I was hearing TCELL.
Yeah.
All right, so I guess I'll pick the last one.
Absolutely, that's the fabricated one.
That's the fabricated one.
Sorry.
Don, don't worry about it. After Travis came up with the four terms, I had to look at the two. I kind of had an idea what Stiction was, right. And I knew that. So anyway, what you and I we met when I was still I was the OPC Foundation president, and I was trying to work with you and trying to figure out how OPC UA fit into, what you were creating at the time. So tell me, I have an idea, but can you tell our audience what was the breaking point and what was, your primary reason for, founding OPA and, at the time of what you did it, without blasting any of the competitors?
No, I won't do that. I won't do that at all during the course of this discussion. But honestly, the motivating event occurred in 2009 when ExxonMobil, did a cost estimate of what it was going to take to replace the control systems in essentially all of the refineries and the chemical plants of the company. And not 100%, but like effectively 97% were all with one vendor. And it was the result of a conscious business strategy of ExxonMobil downstream to effectively sole source for the noble purpose of standardization. The unintended consequence of that is, you give up a lot of commercial leverage on the supplier. Now, the cost estimate for that project and the supplier was basically going to force ExxonMobil, all of those replacement projects would basically have to buy the new product. So it was a $5 billion capital project with essentially no return. And senior management said, this is unacceptable engineering. You need to solve this problem. So three of my mentors in the company that were either in, one of them was Bill Floyd, the chief engineer for control in the chemical company. Then it was Don Gardner, who was the refining, he was in a business job, but he oversaw like computing and OT and IT. And then Mike Sarley, who was I forget what the title was at the time, but he was the R&D program director in ExxonMobil Research and Engineering for automation. So those guys, they were basically the stakeholders for what became funded as a research project in what ExxonMobil calls the breakthrough portfolio, which is where they put all the moonshots. So in the fourth quarter of 2009, I with Bill, Mike, and the other sponsor, we basically wrote the charter for the R&D program that was funded, and we started in 2010. So we did not arrive at the OPA idea until quite a bit of time in the journey of conducting that research project. We spent the first year kind of really studying the problem deeply, trying to identify what the root causes were, both of the technical issues and the commercial issues. And then years 2 and 3, so this would be 2011 and 12. I basically talked to essentially all of the major vendors in the space, and I took advantage of the really good relationships that ExxonMobil upstream had, because unlike ExxonMobil downstream, ExxonMobil upstream basically sourced control systems from a multiplicity of suppliers. And Travis, you might not have been in the industry at the time, but Tom may remember this. So Sandy Vassar ran that program, and yep. he was an ARC forum rock star. If you remember, if you go back in time,
I remember Sandy really well.
He had this way of working. He called it "just happens," and the genius of that was once or twice a year, he would have like an industry meeting. He'd call all the suppliers together and he'd say, guys, this is what we want. So I took advantage of all of those contacts and all the wisdom that Sandy and the upstream controls team had. And, we incorporated that into the R&D team. I don't even remember what we were called at the time. But and then we realized by the middle of 2012, we realized it didn't matter which vendor. If you just jumped from sole source from one vendor to sole source to another vendor, you didn't solve the problem. So I think the next, the light, the old cartoon about the light bulb in your brain going off occurred in early 2013. I was in Virginia at the time, in the headquarters in Fairfax, and I took Steve Bitar and a really fabulous systems engineer in ExxonMobil. I saw an announcement for this conference. It was run by the Open Group, and it was in the Department of Defense. And the title of one of the sessions was Modular Open Systems. And I'm going, hey guys, this sounds like it's what we need. So I took my core team, three guys. Dave Patton was the lead systems engineer. So Dave Patton, Steve Bitar, and I went to this conference, and that's where we got introduced to Lockheed Martin and Dennis Stevens. And we got introduced to some of the suppliers and the technologists who were working in what was called the FACE Consortium, Future Airborne Capability Environment. And it was really driven by Department of Defense procurement that got fed up by basically buying and paying for the same freaking radar system every time they wanted to do a new airplane. So it was really driven by the procurement people who said, this has got to stop. We have to stop buying these vendor proprietary, the terminology they used to call the stovepipes, top to bottom stack of technology. It has to be modular. It has to be open. It has to be based on published interfaces. And when we want to buy something, even incrementally, we want to be able to have competitive procurements instead of being stuck buying from one and only one supplier. And bingo, that was what we needed. And so we started this conversation with Lockheed Martin that really became a very fruitful business arrangement for both of us, business relationship. And we coined the phrase open process automation, I think probably in the late 2014, 2015 timeframe, when we wrote a couple of reports. I had good intentions of getting them published in referee journals, but I couldn't. It was too much for me to do at the time. But we polished them up enough. They were better than internal reports, and we started circulating them in the industry. So people, technologists and business development people started reading these things and started coming to us. And that's when the momentum really started to happen, 2014, 2015. Intel was very fast moving and coming at us with, potential solutions. And that's where the ball really got rolling.
Yeah, I remember back when it first started going, you had your at ARC, you did the presentation about kind of opening this concept up to the world, and obviously it was quite revolutionary at that time. And from an inductive standpoint, we joined the OPAF really early on, and we're ready to come bring in any new standards that were there. But with this one, you had a lot of the big vendors in there, and in the early days of this, Don, where this is a really kind of OPA or OPAS is like a standard of standards, right? You leveraging OPC UA, leveraging others. How difficult was it for you in the early days to get these fiercely competitive vendors to agree on this shared open framework?
Well, it's funny. I have a real live anecdote on that one. The first thing that we looked at for the communications framework, and Tom knows some of the players in the story I'm going to tell. Again, because we had been talking to the defense industry, the first suggestion that came forward for the communications framework for interoperability was distributed data services, DDS, which is it's quite, it's used quite extensively in certain industry verticals, certain use cases, and very, very sophisticated suppliers in this space. And yeah, the one thing that all of those fiercely competing suppliers could agree on was they wanted OPC UA and they did not want DDS. And it's really, really funny that is the first thing that all of these, quote, fiercely competing suppliers actually agreed on. And to this day, I still have, again, I won't drop the name here, but I was the elected forum co-chair at the time. So when I could see the play on the field, and there was this camp that wanted to go DDS, and there was the camp that wanted to go OPC-UA. It was obvious to me for an industrial control solution, there was only one winning path out of that canyon. And that's the one that we picked, and that's the journey that we're on. So that's one. We can come back to the fiercely competing adjective, Travis, over and over again. But that one anecdote about how the choice for OPC-UA was made, and that's God's honest truth. Yeah.
I can still tell you, Don. To this day, Dr. Stan Schneider still probably hates me because he's like, you don't understand, Tom. OPC-UA is not as good as DDS. And anyway, I liked him, and we had lots of good dinners together. And, I tried to put as many resources as I could, into the standard, into OPAS, right? I grabbed, all the different people from my OPC technical group to be part of this, and, I grabbed the Jim Lutz and the Paul Hunkers, and we threw them all there, and, the guys from Yokogawa, because we wanted to I knew what you were doing made a lot of sense. And I knew, because you were well aligned with my whole passion for interoperability. And that was what this was about. And I was excited about it. So we had a lot of good times. So, you basically created the standard of standards. I mean, when you look at what you did, the reality was. So, our traditional, industrial automation has always relied on a lot of proprietary hardware and software silos, So how do you fundamentally protect the end users from vendor lock-in while still allowing the suppliers to make money?
Well, I mean, so you're breaking up the stack, right? But each individual module, I mean, those functionalities are still required. So it's all about defining interfaces so that modular units of functionality, be they hardware or software, can be combined, in a cost-effective manner. But we're talking about open source in some contexts, but this is in general. OPAS is not an open source activity. So there's still protectable IP within the modules, be it hardware, be it software, okay? And the suppliers who win that business will earn the margins on those sales. But the point is, what we want is the ability to compete on the modules. It's like the analogy we like to use is we're slicing up that vertical stovepipe. And now the competition takes place on the slices where we've defined those interfaces. So there's still competition and profit to be made on supplying those modules. So that's I mean, this is not a socialist activity, I assure you. We still want best-in-class solutions, protected IP. We don't want to put any supplier out of business. We want to, help the willing suppliers. I mean, that's the point.
Yeah, it's all about interoperability, so we can have the best-in-class products that you can bring in, and when you're down the road where you need to replace something, you can go find what's the best that's out there today to bring that in. So interoperability is important, but I believe also a big part of this, the beginning here from especially that you're starting it on is also configuration portability, right? Right, where when we replace something, we're not having to reinvent or start from scratch again. I think that was a big part of what you're trying to do with OPAS.
Absolutely, Travis. That's right.
Don, can you talk a little bit about, cybersecurity, right? There's a lot of cyber threats to the critical infrastructure, and they're constantly escalating rapidly. So, what did OPAS do to integrate cybersecurity directly into the architecture versus, doing this as a bolt-on after
Right.
the fact?
So it's so my team and one of my partner companies in the Copa group. We'll get to that later, Tom. But it's very interesting. So we've got like alpha versions of products in development. These are design tools that we're building, system design tools. And the light bulb went off in my head the other day. We were looking at prototypes of these design tools, and I asked the guys. I said, "Look, okay, you're showing me an exploded view of the system that we're building. Wouldn't it be nice for you to add like little graphical elements there to show where the cybersecurity features are in the system? We talked about secure by design, and that's." So I want to walk the walk here now. Today's control systems. Again, I don't want to knock the suppliers. They were designed in an era where cybersecurity was not the threat to the degree it is now. So I'm not really knocking anybody, but you're absolutely right. In at least the systems that were designed a decade ago, the only thing you could do was protect the perimeter. I mean, literally. Now, okay, I'm gonna kudos to OPC UA. Okay, you can use authentication. Okay, so you can authenticate every data transaction in that system. Okay, you can enforce role-based access to elements of that system, and also some of the technologies that we're cross-fertilizing in from IT. There's a systems management utility called Redfish that is a product of the Distributed Management Task Force. Also has basically embedded firewalls that can be placed in basically in every computing device in the system. So you can turn on and off. You can implement the IEC 62443 zone and conduit concepts. Now the IT professionals that they didn't use that zone and conduit. There was a difference in terminology, but the network specialists, I mean, they knew all about VLANs and tunneling and segmenting networks. So there was some learning of cross-fertilization of nomenclature, but now we can build the cybersecurity mechanisms in pervasively in the system instead of just building a Maginot line around the outside.
Yeah, and I want to point out
it really is quite remarkable.
Yeah, absolutely. And I want to point out that while cybersecurity it has to be there from the very beginning, right from the forefront, in secure by design, as you're saying, Don. It also doesn't mean we have to compromise making it. It's not hard. With these systems, we talk about root of trust, where when you have new devices, they are signed by the root of trust that these organizations set up, and so that it could easily be brought in and it be interoperable and plug and play and work. It's not this is to make it harder for the person to build these kind of systems. That was not the goal at all. Right. And then we're starting to see companies like major players like ExxonMobil, where you came from, and Shell and Petronas and many others, who are going from these lab prototypes now to actual field trials, right? Getting POCs and all that in place. So what were some of the big lessons learned with this, if any, when you bring it in, bring OPAS into the messy reality of a live production system?
Yeah, well, I mean, I'll go back and relate our journey with ExxonMobil because they're real tellable stories. When we started the proof of concept with Lockheed Martin, this goes back to probably around 2016. One of the challenges and the learnings was that the suppliers really weren't up to speed yet on OPC-UA at that time. But if I reflect on where a lot of the suppliers are now compared to 10 years ago, much better. Okay, the degree and the sophistication with which they've implemented OPCUA has come a long way in that 10-year period. That's for sure.
It was a lot of work, Don. It was a lot of work to get all the vendors on board.
I mean, that's clearly that's one learning that we had over those years. The other kind of at headline level that I would tell you, Travis, is, and I have to give a kudos to ExxonMobil, the ExxonMobil management team. After the ExxonMobil R&D team completed the second OPA build, which was what they called a prototype, which control was about 100 IO system in a pilot plant with doing catalyst development work. So it was real hydrocarbons and stuff like that. It wasn't continuous operation for a 7-year period like an ethylene plant or a refinery. But we delivered that system. Again, Lockheed Martin was the prime systems integrator on that job. And so after that experience, my bosses said, Don, you've proven the technology. What remains is the business model transformation.
Yeah.
That is what remains. And so I'm going to put that one up there as a candidate for the leading headline above any little technical detail that we fought our way through.
So you're saying no?
I could go on little technical details that we fought our way through, but yeah. I'll leave you with those two. I mean, the fact that the suppliers have gotten much better on OPCUA, and the technological idea is proven. What remains is the business transformation.
Yeah.
Don, what you've done with this project, and you have changed the way the industry operates. Really, you have. You got all the hardware vendors and all the software vendors in line with starting to think about not having a company be locked into a single solution. So how do system integrators fit into the equation? What can they do now with OPAS?
Oh, I think systems integrators are a key, are really a key. So you do not want to compromise, accountability for the performance of the control system, accountability to the asset owner. You do not want to compromise that. So it's the role of the systems integrator to fill that need in the marketplace. Now, what we see, and this is something very vital for my company right now, there are variances. All companies have variances in terms of their capabilities. Now, among that population of systems integrators that are out there, there's some relatively large companies. There's also a lot of, half a dozen guys. It was a family business. There's a range of skill sets and capabilities. And it would be right now. It would be the exceptional control systems integrator that would have the technological capability to assemble an OPAS system. That's something that CSI is doing. That's something that Seaplane is doing. And a better description of the role in the ecosystem that CSI and Seaplane are playing is we're really the platform providers. So when we get a business development engagement, when we go into a project opportunity, we will go in with the systems integrator of choice of the asset owner. And once we understand the requirements of the asset owner, CSI and Seaplane design the instance of the platform, of the OPAS-based platform. And then a lot of the instrument engineering work, the applications engineering work gets done by the systems integrators because they're good at that. I mean, this is the population that you guys, that family of SI partners that you guys have built. These are the outfits that we're talking about. So they don't always have the deep systems expertise that we have built up. But God Almighty, they know how to configure a solution for the asset owner. So that's the symbiotic relationship that we have. But but the systems integrators, I think, are going to replace a lot of what the DCS vendors currently do with respect to doing project services. I mean, that's what I fully expect to happen.
Yeah, and integrators are incredibly vital to the industry, to these efforts. You know, it's really going to help make this open interoperability actually come to reality, and having it work and be reliable and
Yep.
and provide business value. Now, I know you kind of alluded to this a little earlier, but you know, it's one thing to create the standard, and then you have to get adoption, get vendors to support it in their products. You made big headway over the years, but you know, then it comes to companies like Exxon and others who want to be able to go procure and buy these solutions, and it's now they're not buying from one vendor; they're potentially buying from lots of different vendors, and just understanding what's out there can be a little bit challenging, I think, at first, right?
Yeah.
So
Yeah.
this is where can you explain the relationship with with OPAF, and then you know with COPA that started up afterwards,
Right.
you know, the
Right.
Coalition for Open Process Automation, how that come to be, and where is that at today?
Yeah, so the Coalition for Open Process Automation, acronym COPA, you know, when I started CSI in 2020, I had a relationship with Seaplane. I'm gonna talk about CSI and Seaplane to as a lead into COPA. So because this is when I was still working for ExxonMobil. So we first got introduced to what systems orchestration technology is via Seaplane. Again, now this is technology it's coming in from telecom, from networking, pretty well established technology that was not known by the OT industry. So Seaplane came in and demonstrated, you know, the benefits that could be accrued by using systems orchestration. So I saw the benefits of systems orchestration and started a relationship with Seaplane while I was still the chief engineer for ExxonMobil. Then when I retired in October of 2020 and immediately started CSI, you know, we started talking with Seaplane right away, and it took us about I don't know, maybe about 5 months, 6 months of, you know, trying to do the same thing. We both had a goal of commercializing OPA, but we realized we needed scale, and then it was a combination of Brandon Williams, who was one of the founders of Seaplane, who actually took a stint in he became a U.S. congressman. He was a one-term U.S. congressman, but it was Brandon Williams and Bob Hagenow, who's still the CEO, came up with the bright idea. So let's CSI and Seaplane, let's become a partnership. Let's work together. And then to achieve scale, we said, well, okay, we buy into the OPA business ecosystem model that is explained in the OPAS business guide. We said, well, let's assemble a roster of companies, again, you know, the coalition of the willing, to use a George Bush phrase, who really want to join us in, you know, going to market and trying to commercialize OPA. And so COPA, you know, we formalized that in mid 2021. It's not a closed club. There are comings and goings. We like to say that it's not a marketing collaboration. I mean, there's a lot of sweat equity that's involved by the supplier companies, by people performing the platform building, the systems integration work. You know, to make products that are OPAS, you know, conformant to the OPAS standard. There's a lot of sweat equity, but now we've turned it into you know, it is the COPA group of companies is a commercial entity that the asset owners can engage with. The point of contact is almost always right now. There's 3 systems integrators in the COPA group of companies. We put the systems integrator on point, whoever happens to have the business relationship with the asset owner, and that is how we're doing business. So, and Travis, if I look down the road a little bit, so what I certainly have in plan, what CSI plans to do is we're going to be constantly surveying, the technological field to identify those best in class,
Hmm.
most cost effective modular components that again, where the owners of those companies are willing to become OPAS conformant to go through the certification process, which is going to cost them money.
Yeah.
But we're going to be constantly surveying the state of the art for emerging solutions. The whole field of AI, for example, there's going to be an explosion of solutions coming at the marketplace now. So we want to kind of curate. I don't want to say we're not going to be the gatekeeper of everything, but that's a service that CSI aspires to provide to keep this idea evergreen and as a kind of an engine of innovation going into the future.
Yeah, no, we're certainly Inductive Automation is really grateful to be part of COPA. We are a member of that, and I know I love sitting in the meetings with Bob and John, especially kind of help shape where we need to go as a software vendor to make sure that we're conforming, we're doing everything that's needed for these prototypes and these actual live production systems to be working out there. We've been working on things like OPC UA high availability, getting that in the product, getting that native, getting GDS support for the global discovery service as part of this.
Yep.
There's a lot of little pieces, technical pieces that are part of OPC UA spec, companion specs that make all this work. And we want to be a good vendor and make sure that we're putting those efforts forward. And we really like being a part of the group to learn and to see all these different pieces coming together. So I think it's a crucial place. If an end user out there wants to learn more and wants to be able to get a prototype, you go to COPA, right? You have the whole stack, the whole solution ready to go, and an army of integrators who are going to make it happen for you.
Well said, Travis. That means you're spoken from a willing supplier. Thank you very much.
So Don, you already talked about AI, and the whole thing of, industrial AI and, how does OPAS help align with, the modern IT practices, and does an open standard like what OPAS does with COPA, does it help accelerate deployment of industrial AI?
Oh, well, it absolutely does, and the evidence that I would give to support that hypothesis is just imagine the world we used to be in. Hey, you're a software supplier, okay, and you want to integrate with a control system. I mean, there was a day, and there are companies that have done this, had to write like 100 drivers
Yeah.
just to communicate with all the cats and dogs of systems that are out there. That doesn't come free.
No.
Now we're talking about, okay, you conform to the OCF, the OPAS Connectivity Framework interface. And you have a compute resource that's capable of running your application. You're kind of good to go. And that's the world that we're sailing into now. There's so much technical debt in industrial control with, because a lot of the networks were created in a day that preceded, the Ethernet and TCP/IP. So you still have all of this technical debt of these proprietary digital protocols that are out there that have to be worked out of the system. And I'm gonna deviate. I'm gonna show them I'm an old man. I'm gonna tell you a story. If telecom were allowed to operate the way in the industrial control system marketplace is, you'd have nobody talking to anybody around the world. Nobody's phones would interoperate or anything like that. Well, why do our phones interoperate, and why does the internet work? Well, it's because the governments stepped in to protect the consumer. The government is not going to step in to protect ExxonMobil, guys. So, hey, end users, if you buy into this vision that we're describing here today, you can't sit passively on the sidelines, guys. You got to come in and say, look, this is what we want, and you got to actively participate. And that's a call to action to the end users. because this transformation that we're trying to affect for the benefit of the consumers in this market is not going to happen without the active participation of the consumers in the market. So that's, I'm going to not try to editorialize much more than that, but I really wanted to say that.
Don, it's so true.
Yeah, well said.
A best standard is developed by the end users.
Right.
I mean, the end users developing the standards, because then the suppliers got to adopt it. You know, when it goes the other way around, suppliers forcing the end users, that doesn't work.
No,
Never will work that way.
Look at the field bus wars, and you'll see what you're going to get if you turn it over to the suppliers.
I was around through all those field bus wars. Trust me, I still remember Foundation Field Bus and Hart, and I made good friends with those guys. But that was a disaster. But
right,
yeah, and I think this is incredibly important. You know, from a vendor standpoint, standards are what's going to allow innovation to happen, allow for for things to get replaced, not replaced, but migrated, upgraded. Much easier going forward. And really, it's our job as vendors to make sure that our product is valuable, right? That it provides what, helps customers solve the problems, provides what they need. And they're going to get the best in class. So we got to be best in class out there. That's the job. Now, I know there's tremendous momentum with all of this right now, especially Copa's been doing fantastic work, getting a lot of, POCs. And the pipeline is there's now quite a few, I think, that are actually in production, that are completed and ready to go. So what does this look like for the future? How long do you think before it really hits critical mass and this is where everybody's going?
So I think the best telling of the story on how new technologies get commercialized are the books that Jeffrey Moore has written. The one that gets cited the most often is called Crossing the Chasm. I would place OPA still hasn't crossed that chasm yet. It's right at the precipice of the chasm. I think once we get to right now there are 3 OPAS systems in production service as of right now. I think once that count of systems in production service gets to 10, we're going to be on the other side of that chasm, and then there'll be no stopping it. That would be my short answer to your question, Travis.
Perfect. I'm looking forward to that day because I think that there's we'd look at in manufacturing, for example, and automotive, some of these industries where they're bringing in, doing digital transformation, bringing in these technologies like AI and doing all these analytics, and where we can leverage all of these expertise in the process world. And there's a plethora of data that we could start using. So it'd be really exciting to see that come through.
I see the work you did, Don, is truly inspirational. I mean, what you've done, I hope that other industries will take a look at this and realize they could do the same thing, right, from an end user perspective. So I want to thank you for being here today and sharing your stories. It's always a pleasure. Again, you have changed the world, with what you've done. And it really shows how smart engineers with the right architectures can make an impact on an organization. So with that, Don, I want to thank you very much. And I look forward to continuing working with you and making this thing really successful.
Thank you, gentlemen. Good talking to you.
Yeah, thanks, Don. And as always, for everybody, please subscribe to Ignited on YouTube, Spotify, and Apple Podcasts so you never miss an episode. Thanks again, and we'll see you all next time.